Hey everyone, long time no see, but in this video, I'm going to go over Chapter 7, the adolescent brain. So, first, let's talk about the teenage learning stage, right? So, in the last video, we talked about something called critical periods. As a quick recap, sorry, let's pull up my annotation. So, just as a recap, a critical period, oh, wait, that's really, a critical period is defined as a time with enhanced learning abilities. Learning abilities. Okay. So let's dig into what causes this enhanced learning abilities, right? So, first is in the teenage learning stage, there's something called synaptic pruning, which is also known as competitive elimination. So, what our brain does originally, right, is it's going to make more connections than you need, more connections than needed. And then what it's going to do is your brain, it needs a lot of energy to maintain the synapses, right? So in order for your synapses to be sustained, they need energy. But if you're not using some synapses because you made more than necessary, you're wasting energy, right? So what synaptic pruning does is it eliminates the synapses that aren't being used much. Eliminates synapses that aren't used much. And what this allows is it allows you to save energy, right? It allows you to save energy, and this will allow you to reinvest, right? Energy can be reinvested in growing or making new connections that you're actually going to use more. So that's what happens during one stage. And then there's also an increase in neuron connections. So remember, what happens is you're trying to refine by eliminating connections that you don't need, but at the same time, you're learning a lot during your teenage stages, right? So learning means that you're forming new connections. So in your teenage adolescence stage, you're going to have elimination of the synapses that you're not using while also creating new connections. Okay, and you can let me try and erase this a little bit. I hope you guys wrote that down if you needed to. But it also results in increased myelination. So what is myelination? I want you guys to quickly refresh that. Myelination is a process that increases speed of transmission, increases speed of transmission. And transmission will usually only occur when you're thinking, right? So when your neurons are communicating with each other, myelination allows that communication to happen faster. So by increasing myelination, this is going to increase the speed at which you can think, right? So that's why teenagers are able to think faster than children. And this is usually the time where you have your highest thinking speed, right? You're able to think the fastest usually in your adolescent age. Additionally, you're going to be extending dendritic branches. That kind of adds into the increased neuron connections because what that means is that your dendrites are like microphones. They're tiny microphones that are looking to form new connections everywhere. So if this is, say, your dendrite, the small little protrusions on your dendrites are going to be extending, looking for other axon terminals. So say this is an axon terminal. It's going to be looking for it, and it's going to always be trying to make new connections, if that makes sense. Okay. So now something I want to talk about is longitudinal studies, right? So longitudinal studies are studies that look at a subject for a long period of time. So usually what they'll do, an example, the best way to understand this is through an example. Say somebody wanted to study alcohol, the effect of alcohol on in during your teenage years on your life in adulthood, right? So what they're going to do is they're going to study teens who consumed alcohol. And they're going to study them for the rest of their life, right? For the next 65 years. And they're going to see what happens during those 65 years. Any changes in brain chemistry, any changes in their behavior, changes in outcomes, and things like that. So, what it allows you to do is isolate one factor effect on life. So, I have a question for you guys. If a person is studying the effect of um, maternal alcohol consumption or when a mom consumes alcohol during her pregnancies on the effect of her child's financial decision abilities in adulthood, what would be the independent and the dependent variables that they're studying? In other words, what is that one factor that they're studying and what is the effect they're trying to see? Well, if you take a second to get your answer, the answer is they're going to check the factor of maternal alcohol consumption. So whether or not the mom drank alcohol while she was pregnant with the child, and then they're going to study the child for their life and see how that impacts the financial decisions they make, like buying a house or whether that be gambling, things like that, if that makes sense. So basically, throughout your adolescence age, there's increased myelination in the brain, right? But this happens in multiple different areas. So the few main areas that you really need to know about, and this is really usually this is common sense usually if you think about it. You don't really need to memorize, but it helps to put your common sense to it. Um, the first area where myelination increases is going to be in your limbic lobes / cortices, right? So let's think about what your limbic lobe does. Your limbic lobe is basically the area of your brain that works with emotions or it works with impulsivity and kind of the control of pain, control of emotions, and all of that, right? So during your teenage years, you're more teenage. This is why teens are more impulsive and emotional because their myelination is increasing, so their feelings will get stronger during this age. Another part, another area where myelination increases is your prefrontal cortex. So this one, you guys should be able to figure out why. The prefrontal cortex basically controls the way you learn, right? So this is why teenagers tend to learn better or they're able to grasp materials faster because during teenage times, their prefrontal cortex has a lot more connections being made and it increases myelination. Therefore, you're able to learn more materials, right? And the final area where melanation increases is, sorry about that, my mic cut out, but okay. The third and final region where melanation increases is going to be your temporal lobes, more specifically, your medial temporal lobes. Can you guys think of why this might be? So if you guys answered because your hippocampus is there, that would be correct. Um, as a quick reminder, your hippocampus encodes new memories. So that makes sense because in your teenage years, increased melanation means an increased ability to be able to form memories, right? So what does this result in? Well, this results in increased learning capabilities, right? Give me one second. Let me select this and move this up. Move it up here. Okay. So this results in increased learning capabilities because when you remember, increased melanation will usually mean increased thinking power. Increased thinking power means increased learning capabilities. It will, oh, sorry. It will also, however, result in risky behaviors. So what's important with this, right, is the increase in melanation is a good thing and a bad thing. Because when you increase melanation in your limbic lobes, what happens is you tend to be more risk taking. You tend to be more, um, you're willing to take more risks because that part of your brain over melanates. And your prefrontal cortex also hasn't fully developed, which is the part of the brain which stops these risky behaviors. So this is why teenagers are more susceptible to taking these risks. So this is a picture of the melanation of different mammals, I believe. This is of a monkey. This is of a sheep. This is of a human. This is of a chimpanzee, I believe, and so on and so forth. Well, basically, this is at different times, right? So you can see here, like when the human is like a child, they have kind of small amounts of melanation. At 8 years, it starts to kind of increase because that's when you start making more connections. As you can see, this is your cerebral cortex, which is the topmost layer of your brain. You can notice how there's more melanation because it's getting lighter. Lighter represents white matter, which is malin, right? Because malin is white. So you can see how it's kind of getting whiter because more connections are forming at 8 years old. Then at 12 years old, remember this is the landmark of where you start hitting puberty. You can see how it gets significantly whiter here because this is like your prefrontal cortex area. Let me draw it out so you guys can see. Um, so this area right here, where you can kind of see increased white is known as your frontal, or more specifically, your prefrontal cortex. And notice this is the area that is responsible for learning and other parts, learning, impulse management, things like that. So more melanation, it's getting whiter. Then you can see at 17 years old, the amount of connections that are made is insane amounts. Like you can see how everything is getting more and more and more interconnected because you learn the most during your adolescence year. You can see how it's pretty much almost white. That's the amount of connections. And if you guys remember my first video about the neural pathways, the white matter actually marks the neural pathways, right? Because neural pathways are surrounded by myelin, or because neural pathways are nothing but collections of axons, and myelin is located on axons. So all this white represents the new neural pathways that are forming. So if that helps you think about it, more myelin means more neural pathways are forming, and more neural pathways means more parts of the brain are being connected, right? And more parts of the brain being connected means you're able to make connections more. And you can see at 21 and 17, there's a little bit more melanation, but this is where it starts to pretty much stagnate because at 25, I believe, is when your prefrontal cortex starts to complete its development and it becomes your brain starts to stabilize and there's not as much melanation anymore. That's why they say that you're not supposed to make any decisions until you're 25, because that's when your prefrontal cortex fully develops. And it's different for every person, actually. Um, for most people, the age of when you become an adult, this is something you need to know. The age of when you become a true adult is actually somewhere in your mid 25s, mid 20s to your early 30s. This is when everybody truly becomes an adult. And what we mean by adult is when the myelination process starts to stop, or when there's not as much myelination going on anymore, right? So that's what we mean by adult. And the thing is, myelination, what happens is gray matter in the brain tends to progressively decrease. So, in other words, the dendrites and the axon terminals, they tend to decrease with age, but myelination will increase with age because how I like to think about that is myelination increases with age because as you grow older, you make more connections. Older equals wiser because you have more connections, right? So this is what I remember it as. And then in the next video, we're going to be talking about a concept known as plasticity. That's one of my favorite units of all time. It's really about how the brain is able to adapt and mold to its situations around it and kind of adapt, which is a really cool thing to learn about. So yeah, thank you for listening to my video, and I hope it was helpful. Bye, everyone.